Thank you so much for being with us one last time for KB7. As I have mentioned just prior to the recording, this guild session is really intended as a bonus extension pack, and as such, we will be going one level further down to mix some of our own paints because we're the sorts of people who are interested in that kind of thing. This is not to say that one needs to understand all of the code that we will cover today in order to shape culture. It's simply to offer that ability should it interest you and should you feel pulled in this direction, motivated by the specifics and technicalities of some of these new tools. I think that Sparrow did a wonderful job last week, and I encourage you, if you're watching this video in the future, to go and find the one back in the playlist right over there, probably somewhere, and take a watch. Think about what cultural tools, broadly speaking, might look like, because I'm going to present quite a specific means of interacting with them, which I hope will flourish as communal software into a plurality of different uses and proliferation of different places and perspectives. But what you will see now is a very early version of that. And I ask for a few things. The first is your active participation. Stop me if I say something crazy or more crazy than usual, and you don't follow along. Please feel free to provide any comments that you want at any stage, and have some patience with me as I go through these tools, because they are kind of in flux at the moment as a result of all of the different ways that we are learning how to use them together. The idea for this guild, before I start sharing my screen, is that we're going to learn how to code on-chain NFTs together. In particular, one of the great criticisms of NFTs from many technically minded folks is that rarely the code in the contract itself just points at some image stored somewhere. And even if it's stored somewhere in IPFS or Arweave or one of these permanent storage services that are themselves distributed, it's still a pointer, and like what happens if IPFS does go down and there's like a major bug in the Filecoin network, or the same for Arweave or these sorts of things. It introduces a level of separation which somehow feels like a little bit fake. It's not native. The image itself isn't on the chain, so it's not quite the best that we could make it. And as a result of that, a whole bunch of people have spent a lot of time trying to figure out how it is that you can put these collections of images into a contract directly on chain. And that's quite a difficult thing to do, because storing any amount of data on a blockchain, particularly Ethereum, before the merge and even now, is very limited, right? Like storing data on chain is a very expensive action. The actual opcode that does that in the EVM is called S-store, and it's one of the most expensive in terms of gas. That's because when I store data on a chain, everybody has to store that data. So you're having to pay for everybody storing your data, because blockchains work like this, in this kind of crazy and inefficient but also elegant way where everybody stores all of the data all of the time. So this is why we have a limit on the amount of data that any single transaction can put into the network. And it leads to all sorts of interesting results. Like when you're writing contracts, one of the contracts that I was working on for this guild was too big, too many bytes to be submitted in one transaction. It exceeds the gas limit for a given block. The gas limit at the moment is about 8.6 million gas per block, which limits the number of computational steps that can be taken in each block. And so you can't just like write 1,000-line contract and submit that, because it doesn't fit in a single block. And so this has taken us back. If any of you were, COBOL or basic programmers or these kinds of things back in the day, or there've been people who've participated in this guild prior who were part of the demo scene. And the demo scene was this crazy thing that they used to do it on like old school computers where memory was a really, really big problem, and you would have to try and fit the demo, i.e., the introduction to your game, into 64 kilobits, right? Which is amazing, and it's remarkable what people could put into 64 kilobytes. We've become lazy as these modern programs, so much access to compute. I mean, you can do incredible things in 64 kilobytes. It's unbelievable. I will share a video after this, which speaks to that. And it's kind of funny that there is this retrieval in the sense of McLuhan and media theory. There's this retrieval of a focus on memory and data, precisely because of the limits of the networks that we're operating in and the way that they work. So, given all of that background, people sat around and thought, well, how the hell are we going to put a collection of 10,000 images all on chain? If we're not like pointing off at some permanent storage, how do you get 10,000 images on chain if I can't even write 1,000 lines of code in a contract? It doesn't really compute. And the way that you do this is it's a twofold strategy. The first thing that you do is, instead of pointing your token URI function, the thing that when people call, I buy NFT number 10 in your collection, and then I call the token URI in your contract with NFT number 10 as the parameter, and I ask, where is this NFT actually living? And the contract, instead of sending me to a link, the contract can return directly a bunch of JSON, which has all of the information in it required to render the image. So instead of sending me to a link, the contract can format and return, it's called base 64 encoding. You can return JSON directly out of the contract. So we're going to look at that for a moment, just to see how it's possible to give all of the information people need directly from the contract rather than sending them to another link where it's stored. And then we use SVGs, which are scalable vector graphics. And the cool thing about SVGs is, rather than being encoded as blobs like a JPEG or something, which is a whole bunch of like machine readable but not human readable data, SVGs can be coded in what looks, it's basically XML. But it's very human readable, so you can like write the structure for the SVG and then just change little bits of it based on the token number or the message, whoever mints the thing, or what block it was minted at. You can use all of this extraneous information that's available in the blockchain about like the block number or the message.value or the message.sender, or all of these globally available variables, to like alter certain aspects of your SVG. So you write the kind of whole structure, and then you just want to change the color or change the mouth or change the eyes or change the head in the case of nouns DAO, this kind of stuff. You just do that based on whatever you can find. And that is the way that you are able to produce, say, 10,000 images or more without violating the gas limits of any particular block, and without storing an enormous amount of data on chain. So that's the conceptual apparatus for our guild today. What we're going to do now is actually go and have a look at that, because it's one thing for me to wave my hands and be like, this is how it happens. Let's actually go and take a look and see if we can do a bit of a live demo, which is always an interesting experience. The first thing that I would like you to do is to go to this link, if you have not already, and open a wallet, which I'm going to take us through. This is a non-custodial wallet that we have built at Kernel. The reason that we're building wallets at Kernel is because we want to actually create the infrastructure required for peer learning, for actual practical hands-on peer-to-peer learning. And, having been through kernel yourselves now, you will know that we're really good at the relationality, the conversation, the meeting one another where we are. But actually writing contracts, interacting with blockchain data, doing this kind of stuff, it still sort of seems a bit like arcane magic. And we want to try and help with that and actually create environments in which we can have these kinds of conversations coupled with really powerful tools. So this is the beginning of that. And if you're here with me in this guild, then it's probably your first time, and you can create a wallet, give it a nickname. I'm gonna call mine Culture Guild, and some password. I'll just give it one like that. I will generate these keys. It takes a little while. We're using ethers.js in the background here, and what happens is in formatting your keys, we take that password and we hash it about 100,000 times. So that's really, really difficult for anybody to ever figure out exactly what is in this encrypted file that gets produced that holds your keys. You get the public key, your wallet address, and the private key, which you can back up as a JSON file that you can call something. I'm going to probably put it in here. And now that I have created my wallet, backed up my private keys, and by the way, like you can always import JSON files into MetaMask. So you can use this wallet wherever you want. Kernel at the moment only gives you access to test networks because we're interested in education, less so in hyper-financialization. And this will bring you into our wallet interface. There's a lot of stuff to explore in here, and we're figuring out at the moment how to make this more legible, more easy to navigate, less anxiety inducing, which wallets tend to be for most people at the moment. But what we're interested in this guild is the Mint tab. You'll see there are actually kind of three things that we're interested in. I guess I'll go through each of them. The first is the claim tab, and this is how we make sure that you can get some test ETH to play around with. I think that's we should at some stage, if I came back to this page, having clicked on this button, we'll see that my girly balance gets increased. So a faucet is just a way that we have of distributing test ETH on one of these test networks to people who want to use it. There is, I think, a whole session that we can do on like, why is ETH on girly not worth anything, but ETH on mainnet is? What is that really about? What mindset does that point to? There's other reasons too that have to do with the consensus and the number of participants, but these test networks are really just there to enable people to have environments that mimic or mirror mainnet and allow me to like test and deploy and develop stuff and play around with things without actually having to pay, or without it being, committed forever to the history of Ethereum. You can just kind of play around in a less serious, more learning-based environment. So if you've created your wallet, you can always come here and try and claim some girly ETH from the faucet. Once that's done, you can see that there are these two tabs, deploy and mint. Mint is where we're really going to go. I just wanted to show you deploy because this speaks to the theory around peer learning environments and really practical hands-on tools to couple with the kind of patterned exploration in conversation of different ideas. And I just wanted to emphasize that writing an ERC20 contract, your own, right? That's, if you want to just write your own ERC20 contract, you can come in here. It's 4 lines of code. So it's not something that's particularly complicated at first. You might not understand what all of these things is or does, and you might spend some time reading over the contract that we're importing the other work appear on whose shoulders we stand in order to do what we do. But I just wanted to illustrate like that this is really where our minds are at, that if in the first week of your kernel experience, one of the things you do is deploy your own token, that changes radically what you think is possible. It shifts the Overton window, right? And instead of sort of spending 8 weeks only in conversation, which is really important and which we still will continue to emphasize, we also have this other aspect where you can really begin to see, hey, there's nothing arcane, there's no black magic involved in any of this stuff. It's really rather straightforward at this particular level because we've abstracted away all of the, don't worry about getting your own text editor or learning all about the history of Git or figuring out how to write a front end and what language that needs to be put in. All of this stuff, you can just come here, learn about, this is what a token contract looks like. This is what test ether is, this weird notion. And I can play around with this stuff and just see what happens. So that's kind of what these interfaces are about. And what really illustrates it, I think the most, especially if you've never seen a smart contract before, is our Mint interface, where we're dealing with these SVG NFTs. You can see that each of these tabs opens with a template contract preloaded for you. And I will walk through a lot of what's going on in here, but without even really looking at the code first. And note that there's only, I think, 60 lines of code in this entire contract. We can go through just a few simple steps to see what is actually happening in this contract. And that's what I really want to focus on. Just like in the old days, you have to compile the work that you do, which means like you have to take it from this kind of what is called solidity, which is really like a high level language that human beings can read and reason about. And then compiling means taking all of this language and like turning it into something that the Ethereum virtual machine, the EVM, can understand. Right? So it's just like taking the stuff that you can read and reason about and turning it into a whole bunch of like raw data that the EVM can process. And you can see that it's compiled. And if I run this contract, all of a sudden the SVG, the image that is associated with this NFT appears just like that, which is rather magic. We're actually, what is going on here is we're running a emulation of the EVM in your browser so that you don't have to, as I say, like worry about any of the like complications around how to deploy onto which chain, where do I get ETH, how do I then write front-end code that talks to the contracts that I've deployed, what kind of code. All of that is just no longer part of the learning journey, at least as you begin, right? And you just come here with a template contract, you compile it, you run it, and this thing appears. And now we can kind of like step through the contract and be like, okay, like what is really going on here? Like in particular, I can see hello token number 10. So I wonder like where that's coming from. If I go through the contracts, there is this render function, which seems kind of promising because I can read English and reason about it and be like, well, render is probably something to do with how the image is getting shown. And this also seems promising. Here's the beginning of SVG. And as I say, it's really written in like basically XML, which is a slightly older language. It's very similar to HTML. Both of them are markup languages. HTML hypertext markup language, XML extensible markup language. And a whole bunch of stuff is going on here. And if I look, here it is, right? Hello token number something. And then there's like a whole sort of series where we're defining the color and this kind of stuff. So without knowing anything else about what's going on, like I can see hello token number 10 here. If let's maybe just try put anything in and see, well, what happens. And it seems like it's compiled again. And if I run, oh, well, hey, look at that. It really worked. That's kind of interesting. And I can begin to play around with other parts of what's going on in this image. So now it's a little bit longer, and it bothers me that my text is a bit longer than my underline, and so I can see that the width of this is 160. Let's make that 200 to see if I can keep the underline. Oh, not quite long enough. Let's make it 250. There we go. Okay, so that's looking good. I'm feeling positive about that. I can change the color of the text. Why not? Let's see. It's like a fun thing to kind of do. There you go. What happens if I change it to black and change the background here to white? That seems. Oh, there you go. So you can really begin to start like playing around, right? Like I'm being a little bit disingenuous by just sort of playing here, but and one of the things which I sort of still think about a lot as it relates to this work is, you will remember in module 6 perhaps that we linked to a video by Brett Victor in which he talks about inventing on principle. And Brett's principle in life is that creators ought to have immediate connection to what they're creating. And he gives this incredible presentation which covers a vast range of topics, both like animation, game making, but also like electrical circuits and all sorts of stuff, where he's trying to show how you can actually craft interfaces such that the changes that you make are then immediately reflected to you. You can actually like reason about and go into the creative process as quickly as is possible without having to understand like all of the other things around it. You're really interested in like what is happening with the resistance at this particular part of the circuit, or what arc needs to happen across time for the game character to reach that exact place in the screen, which is an enormously difficult problem to try and solve if you're just like in a text editor coding and not seeing the results of these codes, of the code that you're writing. And like, it bothers me a little bit that I still have to like click compile and then run, and that there is this delay in the loop. But like, hopefully you can see kind of how we're trying at least to mimic some of Brett's ideas as it applies to NFTs and get people closer to being able to play with these kinds of things. So, is there a question? No. Right. Before going into how we might start creating slightly more pleasing NFTs than doesn't really work, number 10. I thought I would just quickly like run through like one little bit. I'm not going to spend a lot of time on this, and I'm much more happy to explain this in detail offline. But this is the first part of what I talked about when I set up the conceptual apparatus for this particular guild session. Right? We can write SVGs on chain, and because these images can be encoded in relatively few lines, they're well suited to being put in smart contracts. But the other thing that we have to do is, instead of sending people to some particular location on the internet with the token URI, even if that location is IPFS or Arweave or anything like that, we instead format the data that we want that is relevant to this NFT, and which will allow people to generate the image themselves directly in the contract itself. And so you can see that's really what's happening here. The token URI function, we have written our own, and we are overriding whatever comes from our friends at OpenZeppelin. So this is like the other nice feature about this IDE, is you can import any contract you like from anywhere, from any web URL, as long as it has a .sol extension at the end. You can find and import any any contract that you like. And the one that's relevant here, I don't have time in the skill to go through like line by line the actual ERC 721 enumerable standard from OpenZeppelin, but it's worth just noting that OpenZeppelin are one of the firms in highest standing across the ecosystem. They do incredible audits and have for a very long time been writing these kinds of libraries for standard contracts like the ERC20, ERC721, ERC1155, ERC712, lots of different ones that they maintain and do an enormously good job of. So these contracts as standards are used by pretty much everybody in the ecosystem. And they have a whole bunch of functions to do with how NFTs are specified to behave, one of which is this token URI. And here we import and benefit from all of the functions that they've written, but we write our own token URI function and we override it. So instead of returning some URL as is expected by the, or as is suggested by the standard, not expected, we format our own metadata here. We give it a name, which we specify up here. We say what number it is, which is set at the time that it's minted. You see we set the token ID to whatever the total supply is at that time. We haven't worried about attributes for this contract. And then the image, which is the thing that is displayed, is we tell it that it's going to be expecting some data, which is an SVG and XML form. It's base64 encoded, and we pass back whatever we create in our render function, which is the one that we've been looking at. So I know that that can sound a little bit technical, and I don't want to get too caught up on it, because what I really want to do for the majority of this session is play around with this render function and see if we can do cool stuff with it. The rest of the infrastructure is there. It's nice to understand what's really happening and why it's so cool, why this is like a potentially very powerful cultural tool as opposed to just being like only a playground. Because I think that like one of the great possibilities, certainly in terms of education and open protocols with permissionless use, is precisely that the playgrounds become enormously powerful places. Right. If you remember, it's one of my like favorite points of the whole of kernel, and I very rarely get to talk about it. So if you remember Meili Ko in module, is it 0? It might be module 1, but it's joyful subversion, right? And she's talking about playgrounds. She spends a lot of time talking about playgrounds and reimagining and re-implementing playgrounds, particularly in places that have been overlooked by like extractive capitalism and the global supply chain and these kinds of constructs. So I'm really excited. I'm really excited about these kinds of playgrounds, which give us a more immediate connection with that which we're creating, even if it's not quite perfect, and which put cultural power into the hands of a whole bunch of people. So what I want to do for the rest of this guild is I have created a whole bunch of different templates for us to play with, and they're in this repo. If you go to the contracts folder, the first thing that we'll do is like, it kind of bothers me that this is just black, a little bit boring. I would like to have a gradient there. I would like to have a gradient, and I think that the easiest way of doing that is just like searching gradient image. Let's have a look for this on Google. Like comes up with a whole bunch of nice gradients. Like this seems to be the one that I want. So I want to be able to like import this into my SVG rather than having that like boring old black background. And if you just there we go. That's the one that I want. You'll see that I've already like grabbed this particular URL. Is the same one as this one while I was preparing for this, and there is an SVG image route. I'm going to explain this in one moment, but if you stick with me here, we can put that SVG image in alongside whatever is happening with our text. And let's just make this black. Compile it, run it. Oh my. Okay, so we're making progress. We've got something that looks a little bit nice already. We've been able to import an image. We're playing around with some of the colors. But now, I suppose, is one of the other just scene setting pieces before we really get into like, okay, let's play around with the render function as much as we can and turn this into a party. The last thing that I kind of will need to explain as scene setting is what is going on with this svg.image or svg.text. Like, how on earth is that like making things happen in the actual in whatever is being rendered? And in order to understand that, we've looked already at OpenZeppelin and their libraries and standards, which really help us. And the other one that we want to look at just very quickly is this SVG contract, which is written by somebody called WinterEth. Thank you very much, WinterEth, whoever you are. And they created an SVG library on chain, which mostly behaves like a web API. So if you've ever coded against a web API, you will understand in a fairly straightforward fashion how to use this kind of thing. But basically, the easiest way to explain is you can see there's all of these different functions, something called G, something called path, something called text. And they're like, oh, we recognize text. We're using it when we say svg.text. So what's happening here is like we import this contract and then all of the functions that they've written here, G and path and text and line and circle again, but with no children, and rect for rectangle and filter and C data and gradients and all of the stuff that they've written for us is just immediately available without us having to worry about how to actually handle the translation from like hand coding SVG in Solidity to having it get rendered correctly by whoever fetches this base 64 encoded JSON. And that's really what we've done here. We've called svg.image, right? And you can see that I've given it some URL and then some property, which I've called height. And if I go and take a look here, this is the root that I've hit, svg image, and you can see that it's expecting some href, which is like what we call links on the web, and then whatever props we're going to pass to it. And the only prop that I needed to pass to it was height. The reason that I chose 300 is because that covers the entire SVG that I'm building here. So this is to illustrate that like it's all peers all the way down, right? We're using OpenZeppelin for the NFT standard, for the base 64 encoding library, and we're using this really beautiful SVG library, as well as the utils, the utilities associated with it, written by WinterEth. So huge thanks to both of them. And that allows us to just, SVG image, fetch some random URL, give it the properties we need to make sure that it renders in the way that we want, and off we go. You will see if you're in this repo, and this is the contract that I'm working with. There's the chat. Nice. You'll see that there's a few other things that I've done here. In particular, I've renamed the contracts. I've given it a different name and symbol, Astra, the Latin word for star. And the next thing that I wanted to do is we've kind of like seen already the rectangle that underlines my text. I also wanted to actually like put in a star, right? Like that seems like a cool thing to do. And in order to do that, we really want to create some kind of polygon. And you will notice if you're into this kind of stuff, and again, like if you're not, don't worry about what I'm about to say. But like if you've ever worked with SVGs before, you will notice a few things that are missing from this web-like API, in particular polygons and ellipses, which are common features of many like SVGs on the web, but you'll only find circles here. and you will not find polygons. However, your worries are not long-lived, because there is this generic element, L, and you can give it a tag. So for instance, polygon or ellipsis, if that's the one that you're interested in creating, and then pass again whatever props and children you want to this thing. So if I want a polygon, even though this particular library doesn't have a direct svg.polygon root, you will see that I can just call svg.l. The first tag that I pass it is polygon, and then I give it whatever properties the polygon would ordinarily have, which in this case is a series of points that define the edges of the polygon. And as I say, I want to make sure that my kernel star actually has a star. Otherwise, what are we doing here? That would be funny to have kernel stars without stars. And oh my, there we go. So that's really pretty neat. That seems to take this particular one as far as I wanted to. I will just make sure that kernel star was what I called it, and we can just rename the NFT up here, star NFT, kernel star. And the symbol, we can give it as Astra. So there we were. That's in just a few short lines, we've figured out how to start playing around with SVGs in the browser. We haven't had to learn a great deal about Solidity or what the hell the EVM really is or what it means to run it in our browser. It's not too concerning for now. These are things that you can learn as you go along. But like, if you can follow along here and be like, wow, I can build on-chain SVGs, and there's like 10 people in the world that have ever done this, and that's pretty cool, you know. And you can start playing around with all of these different things. Just literally just play around with the values, see what happens. Stuff will get messed up, but that's wonderful. And you should be able to see various kinds of error messages coming back if you do anything too bad. And you know, that's also something that we're working on in terms of like providing better feedback. But the other thing that I will say about this before I go on to messing around with even more fun aspects of these SVGs is there are other tools that will allow you to do this kind of thing. So in particular, the one that I do just want to honor because they're wonderful is Remix. So, you know, like Remix is a much more mature and advanced environment than kind of what I'm showing you right now. It also comes with like a whole bunch of other stuff, which I highly recommend and which is wonderful to work with. There are a few things of note though, right? And in particular, that's why I spent so much time talking about Brett Victor and this kind of loop between code and creation, and trying to reduce that so that you can really have an immediate connection with whatever it is that you're creating, which I don't think we've fully achieved, but like that's certainly what inspires us. Remix is very much still like a text editor. And the other thing to say is that, you know, like this is a part of a much wider environment. You know, remember the portal page that I showed us first. And not only do you have access to all of the stuff that Remix kind of gives us access to, but a bunch of different kernel things that are going on too. And that social context, that relationality seems pretty cool. Now, the next thing that I wanted to do was, I wanted to do a smiling blob. So this one comes from the good folks at Scaffold ETH, who once upon a time created a series of contracts called Loogies. And what I have done is I have adapted those contracts, which were not written using this SVG library and rather difficult to read, and I've put them all into our SVG function. So I'm just going to copy this and put it in the render, and then we can go through and and kind of have a discussion about what in fact is going on in here. But here's my render function, and if I just drop it all in there and compile, you can see, oopsie, something has gone wrong, which is not great. I think that it's probably that. Having a little, having like better editing is certainly something that I look forward to in this particular feature. And there's also, I wrote one other function which I'd like to discuss over here in a moment, to calculate the color based on the token ID, which I will discuss in a moment. You can see that it's compiled, and if I run this, there's my little Loogie, and he's a cutie. So this is kind of fun. I instead of just like playing around, you'll remember in the previous version that we've got here, we were kind of using the text to make use of the token ID to make each NFT unique. It says like kernel star number 10 or whatever it is, like hello token number 10. And that was like our way of making each SVG unique, which is like, rather like straightforward, but also a bit naive. And here, what I wanted to try and do was set the color of the little Loogie, our little guy over there, little cutie, based on the token ID. Now you can do it in a much more real and advanced way than what I did, which I was running out of time last night as I was putting this stuff together. So I just looked at the main kernel color, which happens to be 6166 BC, which is a particular kind of blue, this blue. And so I just I just played around with this instead of actually thinking deeply about how you could use the token ID with some other features of the environment, like the block number or who minted it or whatever else is going on, in order to generate more variation in the colors. Over here, you're just going to get a sliding scale of different kinds of blue toward green, and you're only going to be able to mint 6,176 before weird errors happen there, so don't do that. But if I do change that calc color thing and compile it again and run it, then oh, hey, it did change. I don't know if that was very clear, but maybe I can go with 3, 5, I don't know. I have no idea what that's going. Yeah, probably. Let's go ABC. Let's see what this does. Not much. Okay. How about D1C? I'm just playing around here to see if I can. Oh, there we go. A nice color change. Okay. So now we're beginning to move on from that first kind of really, really simple one, and try and figure out not just how we can actually draw some cool stuff with the SVGs, which is what I'll go over in a moment here, but also use certain features that are unique to each NFT. And the features that are unique to each NFT are its ID, who minted it, when they minted it, what they paid for it, what the block number was, what the block difficulty was, what the gas. There's a whole bunch of different globally available variables that you can use to try and add variation. And I'm being very specific about using variation, not randomness, because randomness is a different topic and quite difficult to chain. But the rest of the contract is structured in exactly the same way. It's just that we've got a slightly more complicated SVG shape, and we're trying to play around with our little colored guy. He's so fun. And I'm not going to go line by line through this. You can read it, but it's exactly the same as what I just showed with the polygon. We're using the generic elements associated with the SVG library. we're using ellipses this time to make all of this stuff happen. And then ellipses expect certain kinds of coordinates to do with the radius and the, I forget exactly what C is called, but you need those 4 coordinates to make ellipses. And one of the other things that I will say about this is the original Loogies contract that I've adapted this from. They were using a little bit more involved logic to try and figure out how chubby, how fat the Loogie would be, depending on its token ID and a bunch of other stuff. So if you would like to, it's not just color that you can play around with. I've used color here because I thought it was the easiest to illustrate like the next step in making dynamic SVGs. But you could, for instance, the ellipse that has to do with this, with the body itself is this one. And so you could like play around with these values here and like setting them dynamically based on different things that happen during the minting or that are associated with the NFT. And you could like change the, you know, for instance, if I set this to, let's try 140, if I compile that and run it, then, okay, that's not actually what I wanted to do. I guess let's change this to, let's make him a little bit more chubby because that was the original. There we go. And let's make him a little bit less chubby. Maybe it's been a tough year. He's been coding so much instead of eating. Oh my gosh. Now he kind of looks a little bit like a French mustache. That's kind of funny. Anyway, so you can play around with those kinds of things, right? And just see what happens and see what comes of your work. Hopefully it's, you know, a little bit more artistic than me, but I was, you know, just playing around with this is a nice way of trying to illustrate what dynamic SVGs really are and how easy they can be to work with if you're put into a playground that allows you to, you know, begin messing around with this kind of stuff. The next thing that I wanted to look at is a really favorite, one of my favorite projects, and this was written by a man called Simon de la Riviere, and he released it at around the same time that signature economies came out. So I had spent like months trying to figure out all of the stuff associated with signature economies and build it and make it look good and make the contracts function in the way that I wanted it to without compromising on certain aspects of decentralization. And like it had taken me months. And then Simon like wrote this contract called the Room of Infinite Paintings in, I don't know, like a few weeks and released it. And it's just incredible. It's just incredible as an artwork. And so what I have done here is I have, again, sort of gone in and used the SVG library to translate what he was doing. And you know, this will allow us to take a look at it first, and then I will show you how you can kind of begin also to imagine actually making it dynamic, because you can see that I've hard coded the values in here for the color matrix and turbulence and all sorts of stuff that's going on, which I will explain. But that was you know, not what he had put in the original contract, and we'll take a look at something which looks a little bit more like the original contract in just a moment. But if I replace my render function again and compile it, you will see that it's giving me a warning because I'm not using the token ID to do anything this time, which is intentional, and these warnings don't get in the way. This is what actually results, which is really quite remarkable. Simon's work is stunning, and there is so much that goes on in this Room of Infinite Paintings contract. It's over here if you want it, and let me see. There is the Room of Infinite Paintings if you want to go and take a look at the code for it yourself. But there's such subtlety in terms of how he's put together this room of infinite paintings and what that really means, how he thinks about basically like what's most important to understand about this contract is the way that the color is decided, that this color matrix and the way that it's shaded and the kinds of angles that the polygons form and all sorts of stuff going on in this SVG mean that the collection itself is limited to 1 million paintings, basically, because in the calculation for the color matrix, there's something called the minimalism factor. Minimalism as in like the artistic movements, but also like the life movement. And through a series of calculations, the color is determined by the minimalism factor. The minimalism factor is what determines rarity of the artworks and therefore plays around both with the size of the collection, but also the relative value of each piece, which I love this kind of stuff because it illustrates in code. And if you're looking for the real chunky code in here, it's the collection descriptor.sol. And the calculations that I've really just pointed to here, and which I'm not going to go too far into, is this generate color matrix, which, as you can see, is based on a minimalism factor. And the minimalism factor is defined here with a whole bunch of further explanation that he has very kindly left in the comments for people like me to go and learn from. And I love this kind of stuff because this is code as art now, right? It's like we've been playing around with like some fun kind of, oh, look, you can put a star here, you can change the text there. Oh, Loogie, yay. He was a cutie. I'm very much a big fan of my Loogies, but this is a different level for me. And you will see that, like this contract with its generate color matrix and its rooms and base frequencies and filters and gradients and all sorts of stuff is significantly more complicated than me just kind of, putting a linear gradient and a filter or two, and then like a bunch of different rectangles in. But I just wanted to illustrate again that like it's relatively easy to like create a static image, which gives you a great deal of understanding into how these more complex on-chain SVG projects actually work. And then you can work backwards to try and understand, okay, if I want to now take this and actually make it dynamic and like use the token ID to do cool stuff, like what could I do? And my answer to that, what could I do if I wanted to take a look at it, is just in the more trippy. Trip is the room of infinite paintings, which is wonderful, isn't it? Trip. Every part of that project is just truly genius level stuff. And what I have done here in this contract, which I have actually messed up in my last push. So let me go back. I will fix this after the guild. But here is the contract that I'm looking for. And I will explain a little bit of it as we go through. Taking a little moment to copy it, if you forgive me. So I've tried to take what we currently have, where I'm just hard coding each of the sort of aspects of this painting and turn it into a simplified version of Simon's contract. There are a few reasons that I've done this, which I don't have the time to fully explain here. But if I now compile the contract, and if I copied it correctly, I can compile this, and you'll see there's no more error. I can run it. It looks a little different because I'm playing around with different aspects here. But what I've tried to do for you, you can see that the render function now is actually far more simple. It just sets the SVG up as you'd ordinarily expect, but then calls particular functions where we've abstracted some of the creation of the SVG to the gradients, where we're setting that kind of stuff, and in particular to this filter. So we have a little bit of funny commentary from me there, which is actually wrong. But one of the things that I wanted to show you here, particularly if you're going to play around with this stuff, is if you would like to play around, the best place to go is to the FE color matrix, which is where Simon is calculating the whole thing and including minimalism. And that's really the heart of the artwork. And I'm kind of sad not to be able to demo that here because I ran into some problems with the ethers. But how he generates the color, how he links it to minimalism in the artwork, how that's linked to the number of pieces in the collection, the rarity of each piece, the relative value of each piece. That's the beating heart of this entire piece. And I haven't fully been able to replicate that here, but I have at least grabbed a bunch of different color matrices that you might use, and you can play around with them. So if we take a look at this, then begin to see how each one of these affects the color of a given piece. And you can also play around with some of the base frequencies or the seeds associated with each of these, and get to play around with how the image looks. It's cut up and the different stuff that goes along with it. So I will make sure that this contract is accessible for you. I made a mistake in my last push, which happened a minute before this guild. The last thing, if you're willing, because we just have a little bit more time, that I wanted to show you, although it's probably not all that useful, is the kernel punks. I wonder, it might be an interesting project for somebody to play around with, making kernel nouns or these kinds of other on-chain kernel terraforms is something I thought about too. One of the original projects, one of the original NFT projects came much after Freaks and Weirdos, which is still my one true love. Shout out to Sparrow Dada. But one of the other more well-known ones is the CryptoPunks, and somebody went to a great deal of efforts to make sure that the CryptoPunks were also put on chain, and you can go and find that contract here if you like. It's really a rather remarkable contract in many ways, which is it's just, if you ever want to see how far you can take SVG rendering on chain, and this is a good place to go and look. Both Simon's The Room of Infinite Painting and the CryptoPunks are wonderful examples of it. There's an incredible amount of stuff happening in this contract, which I'm not going to attempt to explain in 5 to 10 minutes. I don't understand some of it. These bitwise shifts and things are difficult to really wrap your mind around, at least if you're someone like me. But basically, again, because all of this stuff is open source and it's all there, verified on chain, you can grab it and play around with it in a little IDE. The reason that this isn't super helpful to you necessarily is that you actually, well, let me just show you. I'm going to talk through it. If you set this stuff up, you can compile it and you can run it. So you'll see that it takes a little while and no image is returned, which is kind of what I expect, even though there's this awful bunch of data, function that actually, the debug function in these contracts, if you're wondering, is what renders the SVG in the browser environment, which is why it's useful and why it's included in all of the ones that you'll find in the GitHub repo. But even though there's all of this weird data here, you'll see that no image actually gets rendered. And the reason for that is that what the CryptoPunks did is, the original stuff wasn't fully on chain. They then wrote this contract which was capable of encoding all of it on chain, and then they added all of the features required for each punk, as well as so you can see they finally sealed the contract, but prior to that they added all of the features required for each punk, as well as it might take me a few pages to get through this. And if my internet connection is a bit slow, it's not worth, as well as all of the assets associated with each punk, the chain, the glasses, the cigarettes, the other stuff. So in order to get this contract to work fully and actually render an image here, then we need to add all of the assets and add all of the punks, which was a little bit more involved than I had time to, and which I'm not sure you could do in this kind of environment. But I wanted to show that at least you can compile and reason about these contracts, test them in this environment, and begin to play around not just with hello kernel token number 10, or even fancy backgrounds, or even loogies, or even really incredible trippy paintings, but some of the iconic images of the culture as it stands at the moment, and hopefully help by your own participation in moving the culture in increasingly diverse ways that really speak to that beautiful image which has ruled this whole guild, which is midnight of the mainstream and dawn of the delta. If the delta really dawns, and that delta is like a whole bunch of different tendrils of the river weaving through the landscape in their own unique ways, then we need more and more tools like this, particularly powerful playgrounds that enable peer-to-peer learning, and really powerful playgrounds that enable peer-to-peer learning is a really wonderful piece of work to be involved in, and anybody can, because we obviously require a lot of feedback on the interface and how to make it more intuitive and how to actually use it and how to structure code and all of that kind of stuff, all of the things that makes it truly delightful to use will be wonderful to have with us. So I thank you for your time. I know that I didn't really take questions, and we have 5 minutes. So if you have anything for me, I'll be delighted to hear it. Otherwise, I can stop the recording.
I mean, I would just add, please go and play with these tools, because one of the things that became really hit home a few months ago for me was every single one of us, by each thing that we do, we are creating the culture of tomorrow. Yeah. Everything that we do helps inform what direction that culture goes in. And if we can recreate that delta that Andy references, that great analogy that Ben had, our future is assured, right? Because we have that diversity, we have the ability to adapt. And we can only do that if everybody participates. So please use the tools and feedback to Andy.
John.
Oh, can you hear me? Okay. I don't know if it's a really dumb question, and I feel like I'm the small child standing with a piece of money in my hand and saying, this is not money, it's just a piece of paper. So like these were beautiful SVGs, of course, and it's very nice to be able to write some code in the browser, and here comes a picture. But what makes this into an NFT, or what is an NFT, or what makes this more incredible than simply an incredible SVG?
Wonderful. So let's like, look, I was kind of avoiding that because I'm not sure if the faucet has worked in my live demo, but let's take the let's take the Room of Infinite Paintings. I'm having some problems with my mouse at the moment, you can probably hear. But let's take, excuse me, because it is a wonderful question, and let's put it into the wallet. Compile that just to check. Let's play this together. Let's see if this works. I wonder. It may be the case that well, we'll wait breathlessly because I have not tested the actual deploy function in a few days, and yeah, I'm going to run out of gas because the faucet request did not work earlier, which is a great pity. But the let's see how much Gully I have. So I do have some. The final step here, John, to answer the question, is to deploy the contract. And what's kind of interesting about that, in some sense, right? Like, why is this then just nicer than a bunch of like pretty colors that you can see as an SVG in your browser? Is that like it puts that into like a shared computing fabric, right? And I'm sorry that the faucet has kind of let me down in that final step to show you, like, so that's like, that is the next step, right? That like having like played around, tested, run your thing, you can actually like put this somewhere that other people can also use it and interact with it on their own terms. Like that's critical as well, right? Like, it's not, you don't have to download my tools and my text editor and my environments in order to like play around with these NFTs. Like, everybody has fair and equal access to like the code as it exists in this public ledger, right? And it does, again, like, I don't misunderstand me, I'm saying it's a silver bullet or a panacea, because you still need internet access, you still need like many different things. So it's not like free access, right? In because there's like the last mile problem, and all of these things are still at play. But the distribution of power is radically altered, right? Because, as I say, it's not presupposing that like you have to get like a particular environment set up or text editor. You can like interact with the contract from any internet connection and like do what you want with it. Is it like worth interacting with an NFT contract that's like a room of infinite beautiful paintings? Like, that's a question of aesthetics and choice. I think that the principle is a deep one, especially as it applies to like all of the tools, not just like some collection of artworks that Andy happens to be a fan of. But yeah. So I hope that begins to get it, and I hope that we can explore this together as well, because I don't pretend to have like the answer to that question. I think that it's like a deep and nuanced reflection that, as Sparrow was saying, can actually only be unearthed with each of us like keeping the ball rolling, so to speak. And like, okay, like, cool, I guess I'm like gonna interact with this contract, but like that's kind of boring, and like I don't like that art anyway. Like, let me do that. Like, that's kind of boring. I don't like that. Yeah. So
I was just going to interject with something from an artist's perspective, right? Especially digital artists, and authenticity, originality, ownership. All of those things are things that we can, through shared consensus, prove via the blockchain. So I could take Andy's contract and deploy it and create exactly the same NFTs that he's created. And yet, because we know which contract Andy deployed, even though my NFTs look the same as Andy's NFTs, you can still verifiably prove which ones are Andy's versus mine. And from an artist's perspective, that ability to prove authenticity to me was one of the first things that attracted me into the blockchain space. Just as another perspective, right? It's there are lots of things that having this in a shared permissionless environment allows, particularly if we're all working from that open source perspective. You know, all of the Open Zeppelin stuff that just gets imported is beautiful because it's shared freely. Yeah. And that means we can tweak it, we can override their functions, we can make derivative works, and we can really push the boundaries and do things that the original author would have never imagined. And to me, that's the direction that culture is going in. That remix ability, the ability to tweak and customize and truly make things our own. It's definitely got to be the wave of the future. Beyond that cookie cutter, manufactured, mass production, everything is homogenized feel that we've had for, well, decades, I think. And Charles, you have your hand up.
A footnote or a flag up for another round, but to drop in the mix, as Sparrow has heard about a bit, and Adam, who was here before, and so it's about this license idea that that I'm seeing a gap in what exists. It relates to, Andy, you made a passing reference to nouns and something else, and it also relates to conversations we just came out of at the expo around the folk project, around forking folk. And so long story short, CC0, public domain, is sort of popular, maybe more so and for different reasons, and but it allows the possibility to lock it up later. And so to keep it locked open as a copyleft, I'm kind of fascinated with and just learning about. And there's no, it doesn't seem like there's a thing of pure copyleft, of pure share alike. And I just wanted to.
GPL. The GNU public license requires you to always share it freely. Yeah.
Okay. But that doesn't require the attribution? Because that's what I'm talking about, like without the attribution, it's like the in between. But not to discuss it now, I just really wanted to place it as a marker. But anyway.
Lovely. Yeah, it's a deep question too. I mean, as you know, the development of the GPL and these kinds of licenses, as well as CC0, were done as like enormous cultural statements that actually had more impact often than the software for which they were written. Although that software has been enormously powerful too. The one point I will say on this particular point, especially as it applies to sort of share alike, is that it really completes the circle of this particular presentation in the sense that when like any kernel writes contracts like this, then they become available to all kernel developers. And so like this is again what like iteratively makes playgrounds like increasingly powerful, right? Is that like by virtue of your learning, it becomes possible for others to learn not only what you learned, but more. Because like there's something about like shared learning that compresses the time needed to like learn into like a smaller chunk that then I can go and like learn a little bit more of, right? And so like we collectively chunk these things down so that like it becomes possible to learn more and more and more as we go, which seems to me enormously generative and exciting. So that's one of the other aspects of these shared playgrounds, which I'm really excited for. And the licensing of that will be an interesting discussion to have once the tools have become a little bit more mature, perhaps. So yeah.
Wonderful. Thank you.